Oh, good morning, everyone. Welcome to Cosmic Coffee. I'm Jeff Hall. I'm an astronomer and the director of Lowell Observatory here in Flagstaff, joined this morning by Kendall Edwards, one of our excellent Lowell Observatory educators. Morning, Kendall. Thanks for being with us.
Good morning.
Sadly, our educators haven't had too much to do since we closed in March, but the days are getting longer and the COVID numbers here in Arizona are definitely coming down, and we're really looking forward to getting back to normal maybe or starting to get back to normal reasonably soon. So we've been thinking about Cosmic Coffee for 2021, and as we go through this year, we're going to do the shows in kind of a series of threads. And as we go through each month, in the front part of the month, we'll be talking about just some practical information to help you know what's up in the sky in the evening and how to find your way around the sky and maybe what's going on with some of the objects you see. We'll also talk about how we do astronomy itself. So, today we're going to talk a certain amount about, the brightness and quirks of some of the stars, but how do we determine brightness and distance in astronomy? It turns out that's a really hard thing to do, and we'll talk about that next week. And then in the latter part of the month, we'll talk more about telescopes and instruments, astronomy in society and culture, and the diverse people who ply our trade, as well as some things about the history and people of Lowell Observatory, like we talked about Robert Burnham last week. So as you go along through the year, we'll try to have that sort of consistency, and we hope you enjoy it. So today, we're going to hit our thread, which we're calling Know Your Sky, and Kendall's going to be talking about one of the most prominent features visible right up there. This is a little bit northern hemisphere centric, but after sunset at a convenient time, so you don't have to be up at 3 in the morning to see it. And this is a feature called the winter hexagon, one of the most distinctive features in the evening sky. And Kendall has prepared some excellent slides to help kind of guide us around what we can see after sunset. So maybe we can put up that screen share.
All right, let's see. There it goes.
Yep, that looks good to me. So I think the plan here is we're going to start on the sort of the right side of the hexagon and work our way around it.
Right. So, oops, there we go. So here is the winter hexagon as it would be seen from Flagstaff around 9 p.m. early in February. So one of my favorite places to look at this is up on the Godo. You can have a really nice view over downtown Flagstaff to the east-southeast and see these 6 constellations and these 6 bright stars in them that make up the winter hexagon. So we are, like Jeff said, going to go kind of around the hexagon, or around the circle, if you will, and talk about each of those. And
very good.
Yeah,
looks like somebody kind of sat on the hexagon, though, but it's a little misshapen.
It is a bit misshapen. Yeah, you have to use your imagination, as is with most things in constellation lore. Yep. Here's another view of it from the H.A. Rey book, The Stars. He has a really nice way of drawing the constellations that makes them a little bit easier to see what they're actually supposed to be.
That's certainly true, and this was one of my very favorite books as a kid. I about wore it until the spine broke, and really, it's the most reasonable depiction of making the constellations actually look like what they're supposed to be. And you'll see some pretty clear examples in the show here today.
Sure. All right. So first up is Taurus. So Taurus is known as the bull. Of course, it's one of the zodiac constellations. So we can see that as H.A. Rey depicts it, we've got Aldebaran, the bright red star there, that's the eye of the bull, and a couple other really interesting clusters that I'll let Jeff talk about in here as well.
Okay, yeah, and one of the things when we look up at these stars that are really bright, they appear bright. This is going to sound silly because they are bright, meaning they're intrinsically luminous. But, very luminous stars are among the more rare ones in the galaxy. Aldebaran is a little bit of a difference in that it's only about the same mass as the sun, just a little more massive, but it's what we call a red giant star. And if you look up in the sky tonight or when it's next clear, you'll see that Aldebaran looks distinctly orange. It's a big, bright, cool star. If you plunked it down where the sun is, it would probably fill up space a little past the orbit of Mercury. So it's a pretty big beast, very much like what the sun will be about 5 billion years from now. So that's the bright red giant star. And then Kendall mentioned these two interesting star clusters, the Hyades and the Pleiades. They're both quite young. These are what we call open clusters. They will eventually dissolve because the stars, their mutual gravity is not that high. And over time, encounters will cause stars to be flung out from them, and they gradually disperse, unlike globular clusters, which are much longer lived. But these are very interesting astronomically because the stars in a cluster are all at the same distance. And so their relative brightness corresponds to their actual brightness distances. And we can use clusters to understand quite a bit about the physics going on in different types of stars. These are very distinctive. The Hyades look more spread out because it's closer. And I'll note Aldebaran is actually not part of the Hyades. It's lying in the same line of sight. It's actually pretty close by. Another one of the reasons it looks so bright. But here's an example, I think, Kendall, where H.A. Rey has drawn something here that actually looks like a bull, as opposed to this weird, green arc in the star chart that you see at lower left.
Exactly. Yeah, I like that he uses the head and the eyes there instead of making those long parts, the horns. And of course, Taurus is really easy to find in the sky. If you can find the Hyades, which is a V-shaped cluster of stars that, like Jeff said, look fairly close together because they are in a cluster. And then the Pleiades, which are, really easy to spot. They're almost like a little mini dipper, a little bit misty because they have some nebulosity associated with them. But the Pleiades are prominent in many cultural myths and stories, and they've been used over the years to mark the seasons. So the Pleiades is known as the Seven Sisters. And some people say you can see 7 stars. I see about 6 from a Flagstaff, which I think is fairly normal, kind of for decent eyesight. But there's a lot of myths around the lost seventh sister, which could be based on historical facts of one of the stars kind of dimming over time.
Right. Yeah, I don't think my aging eyes are good enough to pick out 7 anymore, but you can see several, and it really does look like a little tiny dipper up there, and certainly a spectacular thing to see. For instance, through the tech up at the Godo.
Yeah, the tech is really the best telescope to look at it. We get that wide field of view where you can see so many of the stars. So there's only about 6 visible to the naked eye, but when you look through even just a nice pair of binoculars, you can see quite a few more, and some of that nebulosity, that cloudiness I was talking about, that's associated with the I guess it's not associated with the original cloud. Is that true, Jeff?
Right. It's we call them reflection nebulae, and it appears they may simply be, the galaxy is filled with these clouds of gas and dust, and if a bunch of bright stars happens to be moving through one of these regions, then the radiation from the stars is stimulating the gas and dust and causing this beautiful emission, this bluish emission you see around these stars.
Yeah, definitely one of my favorite things to look at. And of course, we can always find it using Orion, which is another easy constellation to spot in the sky. If you can spot his belt of 3 bright stars, then you can draw a line straight through those belt stars to Aldebaran, which is that reddish, fiery eye of the bull. And then, notice that V-shaped Hyades pattern and the little bitty Pleiades mini dipper there. So it's a nice one to be able to spot in the sky pretty easy.
Yep. Okay, and so there is one question asking how the Hyades formed. And as stars do, they condense out of cold, dark clouds of gas and dust in our galaxy. And you see a lot of clusters because often these clouds fragment into many different nearby little blobs that then condense into a cluster of stars. We'll see this in some of the other objects in today's show. And then over time, those clusters gradually disperse as the stars move around and interact with one another. Okay, so Aldebaran is star number 1 in the hexagon. Where's number 2?
All right, let's flip the slide here. And we're going to we're kind of going in a counterclockwise motion here through the hexagon. And we're going to Auriga. So Auriga is known as the charioteer. I don't see a charioteer often when I look at this shape of stars. You can see in the bottom left corner, it's traditionally drawn kind of like a pentagon, sharing that bottom star with Taurus. H.A. Rey depicts it as a guy with a cap on and his nose sticking out here, which I really like. But Auriga is often associated with goats. In fact, Capella, the bright star that's part of the winter hexagon, means the little goat. And the 3 stars that you see in a little triangle down here are often known as the kids. So this is traditionally associated with the myth of Zeus being suckled by the goat Almathia. But yeah, over the centuries and over the years, it's always kind of been associated with goats, which is sort of funny.
Yeah, right. And of course here, instead of the kid, it's more of a nose, because this is the charioteer, who I suppose could be a guy or a gal. But yeah, a little face there with kind of a cap, and Capella, the bright star, is an eye. And, you know, when you look up at these bright stars, you see this individual point of light. But as we well know, most of these stars that you see in the sky are not just one. There's actually more of them. And it turns out Capella is actually a quadruple. We see a lot of stars in the sky that are pairs orbiting one another. We call these, sensibly enough, binary stars. Binary stars long ago were the topic of my PhD thesis, a particular type of binary star. And then sometimes you have a situation where you've got 2 binaries orbiting one another in a bigger binary, and we call those hierarchical binaries. And that's what you could see if you took a spaceship and flew out to Capella. It's kind of see 2 big stars and 2 little faint wimpy ones that are not even close to being visible without optical aid, orbiting one another. So it's kind of a neat system. And then another interesting star is the one that's labeled Epsilon right there. This is Epsilon Aurigae. And the Epsilon is, we call that the Bayer designation. It's a system of designating stars and constellations developed by Johann Bayer in the 18th century. And Epsilon is a really bizarre eclipsing system. Every 27 years, there's this giant eclipse, and we think there's 2 stars and a massive cloud or disk of dust around one of them. So you have these eclipses that take 2 years to happen. And the most recent one was about 10 years ago. So, you know, hold your breath, watch our website, only 17 more years, and there'll be another eclipse here to show you.
Yeah, it's a really interesting kind of mystery, that little pair, or binary pair with the big dark ring of dust and things that go around it. So that's fun to look out for.
It's one of those ones that's been tricky for astronomers to figure out what's going on.
For sure. One other interesting fact about Auriga is there's several nice binocular clusters that you can see in Auriga if you point your binoculars up. M36, 37, and 38 are all in that region, which are nice open clusters to look at.
Yep. And then there's a question in the chat about barycenters. So you know, the barycenter, of course, is the common point around which a double system of something orbits, and anything like that. You know, there's an Earth-Moon barycenter, Pluto and Charon. Actually, the barycenter of that system is outside Pluto, which is why you see them doing this. And then if you have a hierarchical, I think you would just refer to the barycenter of the overall system, since the 2 widely spaced doubles kind of act as point sources of their own, orbiting around the sort of higher level barycenter, and then the individuals have their own barycenters. So, all right, so Aurigae, a prominent constellation, well up in the sky because it's somewhat farther north. We're up at the north side of the hexagon. So, proceeding around, which one is the next one? Yeah, okay.
Yeah, we've got Gemini next, the twins. So this is another zodiac constellation. So many of you will be familiar with it. Known as the twins because of these bright stars, Pollux and Castor, that appear to kind of move together through the sky. And for centuries, people have looked up at them and thought of the twins whenever they see them. I like the way that it's drawn here, that they're holding hands. So Castor and Pollux traditionally were brothers in Greek myth, but one was mortal and one was a god. And so in death, they would be separated, which was sad. And so Pollux, I believe, was the immortal one and begged Zeus to be allowed to stay with Castor, his brother. And so in honor of their friendship, Zeus put them in the sky here. So I think that's a fun story of friendship. That's what I think of when I look up at the twins.
Yep. Right. So this vertex of the hexagon is sort of a pair of bright stars. Castor is actually designated Alpha Geminorum because Bayer got his brightnesses backwards when he was and typically when you have this Greek letter system, Alpha will be the brightest star in the constellation Beta, Gamma, Delta, Epsilon. In this case, it's actually backwards. Castor is another one of these examples where it's just a crazy star system. There's actually 6 of them, and there are other sextuples out there. Mizar, the famous the star in the bend of the Big Dipper. That's the famous vision test between Mizar and Alcor. Mizar is also a sextuple, and some of those stars are so close together you can't really separate them visually. You have to do it spectroscopically. But a very nice zodiac constellation there. Of course, not quite as fine as Scorpio, which is my sign, and we'll get to that in the summer. Definitely the finest of the zodiac constellations. So, what are you, Kendall?
I'm Cancer. I'm seeing the crab right here.
Okay, right up there.
Loving the beehive cluster in the Cancer constellation. So
yeah, that's a nice little constellation. You have to kind of look hard because you can see clearly from H.A. Ray's symbols there. Those are 4th and 5th magnitude stars. So it's fairly dim, but really nice object, that cluster in it.
Right. Yeah, I'm able to see it, at least from the Godo kind of naked eye. If you use peripheral vision and look up towards Cancer, you can see a little fuzzy spot there marking the beehive cluster.
Right. Okay, so onward to our 4th vertex. I see it there. Yep.
All right, there we are at Canis Minor, the little dog. It looks more like a hot dog, I think, than an actual dog.
Right. I've always wondered, this is one of these constellations where there's 2 visible stars, and obviously one of our ancient ancestors, looked up at the sky and said, "That's a little dog." I mean, what were these people smoking? Sometimes I wonder.
I wonder. Yeah. So I guess the little dog goes along with Canis Major, which we'll get to next, the big dog, but they're Orion's hunting dogs traditionally. And Procyon there is the bright star that's actually means before the dog. So it rises, or it did actually rise before Sirius. Now, if you were in Egypt, I think I've read that it would actually rise right around the same time or even after Sirius.
Yep, and Kendall, going quickly back 1 vertex on the hexagon,
sure.
Teresa Clifton asks, where can I find the twins tonight?
Oh, good question. All right. So one way to find them is through the Big Dipper, which we were talking about. You can draw an imaginary line kind of diagonally through the Dipper's bowl, and it goes right through Castor and Pollux. But another way, which is more in line with the winter hexagon that we've been talking about, is if you draw a line through Rigel and Betelgeuse in Orion, which we're going to get to on our last slide here. You can draw a line straight through them and it'll pass right between the twins, Pollux and Castor.
Right, so you're going north from Rigel through Betelgeuse, right, and up to these very 2 bright stars. And as you can see, there's not a lot of other bright stars right around them. So they're pretty distinctive.
Right.
Yeah.
All right. So back to the little dog here. Let's see. This one actually is also a double star, right, Jeff?
Yeah, and it is a binary star. And so there's this very faint companion to Procyon there. It's also, this is one of the stars, there are 2 ways that a star can appear really bright in the sky. It can be intrinsically luminous, so it's just emitting a tremendous amount of radiation just because it's very bright, so it'll look very bright even if it's fairly far away. Or if it's a more normal star, it can look bright just by virtue of being very close to the Earth. And this is one of our closer companions. It's only a little more than 10 light years away. So it's very much right in the solar neighborhood, not a particularly luminous star, only maybe several times that of the sun instead of hundreds like Aldebaran, but very close by, which is why it's one of the brightest stars in the sky, despite being in a very inscrutable constellation.
Right. And Procyon is actually part of an asterism that makes it a little bit easy to find as well. You can draw a triangle between Sirius, which is the brightest star in the night sky that we'll get to next, and Betelgeuse, and get a nice little triangle there, which helps to find this little dog.
Right. And comment in the chat from Chris Georgie. I wonder just how much the limiting magnitude has gone up since the advent of widespread light pollution. Well, it's a good question. And it, of course, it depends on where you are. And so in a nice, pristine, dark sky area, the limit of human vision is down around sixth magnitude for really eagle-eyed people. I can't see that faint. I think fifth magnitude stars are pretty faint. Even in a medium-sized city like Flagstaff, if you have good dark sky protection like we have here, I can clearly see every star that makes up the main shape of the Little Dipper, Ursa Minor. And of course, right. The point of the Little Dipper's handle is Polaris, the North Star, but the other stars in the handle are fifth magnitude, and they're clearly visible right in Flagstaff. So even in a medium-sized metro area, you can do well. Now, in big metros, I can tell you, a year ago, one of my last trips before the world fell apart, I had a quick trip for an astronomy talk in Los Angeles. And Orion's belt was about the faintest thing I could see walking over to give my talk. And those are second magnitude stars. And so the limiting magnitude in major metro areas is these second magnitude stars. And, there's only one of them on this whole plot. Basically, Procyon is the only one. And there's one right down there in the lower right. So a lot of the sky disappears. And we estimate now 75 to 80% of the population of the United States lives in a spot where you can no longer see the Milky Way. And that's really a shame.
That is, yeah. I'm really thankful for the dark sky protections that we have in Flagstaff and how it's really spreading too throughout Arizona and throughout the world. The focus on keeping the skies dark so that we can see those gems up there.
Yep. Now, somebody was commenting, Glenn Frank was commenting about Sirius dogs, and I think we have a Sirius dog coming up next in our hexagon.
We sure do. Here he is. Sirius is the dog star in the big dog, Canis Major.
Right, and so this is pretty low in the sky, as is a fairly southern constellation, and I think he sort of appears like he's kind of standing on his butt as we see him in the sky, right?
I like to think of Sirius as his collar, so that's the little gem on his collar right there. And then, his head is pointed up and his tail pointing down. That's one of the constellations to me that looks actually like what it's supposed to be when I look up in the sky.
Yeah, really. And particularly the way Ray has drawn it here, as opposed, you look down at lower right and, this is a dog that has had an unfortunate encounter with a steamroller as far as it kind of looks there. I don't know what they're trying to depict.
He's been smooshed.
So Sirius here is another example of a not so luminous star that's just bright by being virtue of nearby. And in fact, it's the brightest star in the sky, other than the sun, of course. It's also a binary, but it's a really interesting binary because the companion is Sirius B, is a star we call a white dwarf. And so this is the dead core of a star that has evolved and ended its life. This is exactly how the sun will end its life 5 billion years from now as a white dwarf. Incredibly hot, dense, tiny object orbiting Sirius it's not too far away. I think it's like the distance of Saturn or Uranus or something.
Yeah. One of my favorite things is, have you seen in the gift shop the planet plushies that we have? They're the little kind of stuffed guys of the different planets and some stars. But one of the stars we have is Sirius A, and tagging along with it is a little tiny Sirius B. It's very cute.
Tiny Sirius B. And this is, white dwarfs are incredibly hot, but they're very, very small. The white dwarf companion to Sirius is probably only about the size of the Earth. And as a result, it's incredibly faint. You cannot possibly see it without optical aid. And that's because the luminosity of a star is higher if it's hotter, but it also depends on its size, because size is, how much surface area does the object have available to radiate through? And these poor little white dwarfs are just teensy compared to their companions.
Yeah, on a good night up at the Godo through the 32-inch star structure telescope, you can definitely resolve Sirius A and B, which is kind of fun.
Oh, that's awesome. And it's awesome to be able to show people that and say, okay, you are now looking at the exposed dead core. There's this giant ball of carbon and oxygen atoms with a little bit of lighter stuff around it. And to actually be looking at something like that and having those photons hitting your very own eye, it's a neat experience.
It really is, yeah. So Canis Major, again, one of Orion's hunting dogs. He's the big dog, of course. And if you've ever heard the saying, the dog days of summer, it actually comes from this because Sirius was used as a marker in ancient Egypt for that signaled the annual. Well, so when Sirius would come up just before the sun, they call that a heliacal rising, it would signal the annual flooding of the Nile. And so they knew that, to expect that flooding, which was destructive, but also brought kind of life and rebirth to the area for agriculture. But this was in the hot days of summer. And you can imagine, as Sirius was behind the sun during these times, ancient people thought actually maybe the heat of both the sun and Sirius was scorching the earth during the summer.
Right. Yeah. It's been a significant star for thousands of years. Question in the comment, is the companion sufficient to distort the shape of Sirius A to the point that it's flattened? Answer, no, it's probably too far away. Where we see heavily flattened stars, and there are certainly some extreme examples like that. When we get to the summer shows, we'll talk about Altair. In the Eagle, which is rotating so rapidly it's about to fly apart. So there are a number of stars indeed that are visibly egg-shaped, and that's typically due to the flattening of their own rotation. We do see binary stars, for example, where the disks are, the star itself is distorted, and actually where the stars are so close together that we call them semi-detached binaries. So there's material from one big star that's flowing onto the other one because it's gotten so close that it's being dragged off by the other star's gravity. But those are typically really close binary stars where they're, the orbital period is a week or less for some of these. So that's the answer there. Okay, and then we'll go to the last stop where there's actually a lot to talk about because this is probably the most dramatic constellation in the whole sky.
Sure. And Orion, the hunter, is very easy to spot as you're looking kind of southeast in the night sky in early February. You'll see, of course, the prominent belt. So these 3 stars in a row here make up Orion's belt. And then we have Betelgeuse, the big red giant, supergiant, that makes up his shoulder. It's actually in Arabic often translated as the armpit of the giant. So you can see that there, well depicted. And then Rigel, which is another really bright star. But there's so much to talk about as behind Orion or in the Orion constellation in that area of the sky is a great big cloud of dust and gas where stars are being formed.
Yeah, it's definitely a dramatic constellation. And we can take a quick detour into popular culture here. We were just talking about Sirius in the big dog. And now we see Bellatrix here in the other shoulder of Orion, and Harry Potter fans may be pricking up their ears at that point. When we get to the spring, we'll talk about Regulus in Leo, and J.K. Rowling clearly drew on stellar names for some of her characters there. This is another example where you can see stellar temperatures at work because Rigel, which is part of the hexagon, is this brilliant bluish white star, and Betelgeuse up in the other shoulder is incredibly red. In fact, I would encourage everybody scroll back in our YouTube feed to the very first Cosmic Coffee from last March, and we did that whole show on Betelgeuse and the weird dimming episode. That show was with Dr. Phil Massey, who's an expert on huge luminous stars like we have in Orion, and it was a really interesting conversation about what was going on a couple of years ago with Betelgeuse. The situation here is, Orion's belt stars, Rigel, Betelgeuse, these are all what we call supergiants, incredibly massive stars, huge, hot, luminous. These belt stars, if you plunk them down where the sun is, these are stars 50,000 times, maybe 100,000 times in the case of the central star, the luminosity of the sun. As a result, though, they don't live very long. So this is going to look real different in just a couple of million years.
Mm-hmm. I hope I'm around. No.
Yeah. Again, we'll have a supernova party when these things start blowing, and that's how these stars will end their lives as supernovae. Betelgeuse could literally go tomorrow, or it could go in 50,000 years. So don't hold your breath.
Right. I know it was very exciting last year when it started dimming. Everybody kind of thought, "Oh, is something changing? Are we going to see that?" But I loved the title of Phil Massey's paper that he and Emily Levesque wrote on Betelgeuse. That Betelgeuse just isn't that cool. So they couldn't attribute the dimming to a cooling of the surface temperature. Rather, it was kind of a big mass of gas and dust that was ejected from the star. Right.
That's right. That's the conclusion they came to. It was a really nice result using some very very clever spectroscopic analysis of what was going on. Of course, everybody was hoping that this was a sign of instability. Because everybody wants the supernova, and I was kind of rooting for it too. Although poor Orion would then look rather different.
Right. Yeah.
So let's talk a bit about M42.
Yeah. So that is probably one of my favorite telescope objects. I look forward to the winter, not because of the cold up on the Godot deck, but because of getting to look at M42, which is known as the Orion Nebula, through the telescope, and especially through the star structure and the 32-inch telescope up there. It is just incredible. So it's a star forming region that, new bright hot stars are forming, of course, new in astronomical terms. We see some that are, several million years old. But we do have a picture that's taken with another one of our telescopes up at the Godot. So we have a 14-inch plane wave up there with a Malin cam attached so we can take longer exposure photos. So our eyes just aren't that great at capturing colors in the dark. And so when you look through a telescope, you see something that's amazing, that's kind of holographic, and you see these bright stars in the center. But when you get a little bit of a longer exposure, like this one that was taken by Hannah Zygo, one of our other educators up at the Godot, you can see just how interesting the structure of the gas and dust and these bright stars at the center, in order to take this long exposure, actually get a little bit blown out. But it's just a gorgeous object to look at.
It sure is. And then of course, right down at the center, we talked at the start of the show today about star clusters. And there's this little cluster right down at the center of the nebula called the trapezium. And these are really massive new stars joining the galaxy. So as Orion gradually blows himself to smithereens as his stars go supernova, new ones are going to be joining the galaxy, and they're just going to be as bright and luminous as the old ones, because these are really massive stars, much more massive than the other ones we've been talking about today.
Right.
All right. So that, and we can point out, if we go back to the slide with like the whole hexagon as we wrap up the show here.
Yeah, this one or the one before, the Stellarium one?
Yeah, that's a good one. So when did you say this was? Like mid-evening, about 9?
Yeah, around 9 p.m. So looking south from, mid-latitude North America, like Flagstaff, this is what you would see looking out. Yeah,
and Betelgeuse, you can kind of peg it not quite in the middle of the hexagon, but that's going to be like a really very deep ruddy red central point, and then these very prominent stars in the sky all spanning around it. So if it's clear where you are, go have a look and check out this neat site in the southern sky. And certainly you don't have to do it tonight. This will, for the next month, it's going to be up there, gradually moving west as February goes along. Mm-hmm. Yeah. So we've had just a couple of questions in the chat. Chris asks, what's the metallicity of the belt stars? It varies. I'd have to look it up. I don't think stars like Rigel and Betelgeuse have metallicities radically different from the sun. It's actually fairly similar, but I'd have to look up the exact values. And for all of our viewers, metallicity, astronomers are very simple-minded beasts, right? So the periodic table of the elements for astronomers is hydrogen, helium, metals. Okay, and so the metallicity of a star is basically the fraction of anything heavier than helium, and we typically refer to that relative to the sun. And some stars are a little metal rich and some are a little metal poor. I don't think these stars differ massively from solar metallicity, although there are some that really do deviate by a factor of 10 or more. Here's one, Kendall. If someone was observing the night sky from Andromeda, do you think our sun would be part of a constellation from their point of view? Well, not from Andromeda, but maybe from some nearby stars.
Yeah, so from Andromeda, you wouldn't be able to pick out those individual stars, just as when we look at Andromeda galaxy through our telescopes, we see just kind of a fuzz. That's the light of, trillions of stars even, all combined together. But maybe if you were looking from like Alpha Centauri or a nearby star, maybe even a little further away, I don't know. That's an interesting thought.
It would. The sun would be, limited, because the sun's not very luminous, right? So if you're only 10 parsecs or about 30 light years away, at that point, the sun is about fifth magnitude, just a little bit brighter than fifth magnitude. So it would be akin to these stars on AJ-Ray's plot that are just the little dots, one of the fainter stars you could see. So it would only be people living on stars or not living on stars, of course, but planets around the stars, fairly close to the sun. It would be a pretty unassuming star. But that's actually an interesting question now. How bright would the sun appear, say, from Alpha Centauri? 4 light years, which is only, it would be reasonably bright. One of the brighter stars in the sky. We could actually look at that for next week's Cosmic Coffee, because apparent and absolute magnitude are one of the things we're going to talk about. And then last question I see, Barnard's Loop. So is that part of the Orion Nebula? It's part of the whole molecular cloud complex there.
Right. Yeah, there's just a ton to see in there, from the Horsehead Nebula to, there's just great viewing all through that Orion molecular cloud complex.
Right. And we sometimes call these stellar nurseries, because this is where new stars are being born. We do the Horsehead with the Malin cam, don't we?
Yes, we are able to get that one. Yeah, so that's a really nice photographic object. Not able to see with the naked eye, but yeah, this is actually the nearest star forming region to us. So it's a fun object to look at.
Okay, so we'll ask for any final questions and say thanks so much to Kendall for all the stories and for putting the show together here.
Right.
So hope you enjoy this. You can, as noted, you can go out throughout February and see this feature. And so what we're going to do, we've talked a lot today about some of the brightnesses of these stars. So next week we'll talk a little bit about how we figure out how bright things are and how far away they are. And the farther away you go, the harder it gets. So once again, thanks a lot, Kendall. Been a lot of fun on the show today.
Yes.
And we'll be back in early March with another show about some spring constellations in the Know Your Sky series. So until then, stay well, stay healthy, and we'll see you next time.
Thanks, guys.